Hi class. In this lecture here, we want to begin our study of trigonometric equations, or basically how to solve trigonometric equations. And so this video is going to start a long lecture series on how you find all solutions of trigonometric equations. Okay, so this is going to be the objectives we're going to work through. So basically what I want to do over a 6-video lecture series is I want to show you, all right, how to use multiple methods and techniques to solve a trigonometric equation. Okay, so this first lecture here is going to be kind of an introduction to solving trigonometric equations, and what I call how you solve quote-unquote simple trig equations. All right, and then I'm going to break this up, and then lecture number 2, I'm going to talk about how you solve multiple angle trig equations. Lecture number 3, I'm going to talk about how you solve trigonometric equations quadratic in form, and also then by factoring. In lecture number 4, I'm going to talk about how you use identities to solve trigonometric equations. Lecture number 5, then I'm going to talk about how you use a calculator to solve trigonometric equations. And then I'm going to come back and then I'm going to record another video for you just on extra examples, stuff that's, not that doesn't come up in the previous 5 lectures, and also just some extra problems. So in all these lectures, okay, basically it's just going to be a ton of examples. Okay, so I highly encourage you, as you're watching this lecture here, consider after I put up a problem or two and you get a sense for how they're solved. When I put up another problem, pause the video. Try solving the problem before I solve it for you, and then after you solve it, unpause the video and see if you get the same thing here. Okay. So first off, all a trigonometric equation is an equation that contains a trigonometric expression with a variable, okay, such as sine of x. So like this will be the first equation we actually solve, all right? So the first problem we're actually going to solve is going to be something like this. Sine of x is equal to the square root of 3 over 2, okay? So the values that satisfy such an equation are its solution. Okay, and there are trigonometric equations that have no solutions, all right? But when an equation involves multiple angles, all right, the period of the function plays an important role ensuring that we do not leave out any solutions. And so, like what I mean by multiple angles is something kind of like this, and we'll do a problem like this. When does sine of 2x, something like this, equal 1/2? Okay, this 2 in here tells me it's a multiple angle. All right. To solve here, all you're going to do, all right, to solve an equation containing a single trigonometric function, and I'll do some problems later on maybe, that have, multiple trig functions, but just a single trig function. All you're going to do is you're going to isolate the function on one side of the equation, and then next step you're going to do is you're going to solve for the variable. I'm going to show you how to do all this, okay? It's going to be, we'll start very, very simple, and then we'll keep building and building and building on this. All right, what's going to be our biggest helper here, okay? And what you're going to notice for almost all the problems, except for the ones that involve using a calculator, is the unit circle here is going to be a big help, all right? And you're going to notice on all the problems I do, okay, I'm going to say, okay, well, let's look at the unit circle. Let's reference the unit circle. So keep this handy, okay, as you go to do your problems. Just have the unit circle right there with you, okay? And I'll show you how I read it as we go through the problems. Okay, so there's going to be 2 types of ways we can solve this. All right, these problems. So this first problem, sine of x is equal to the square root of 3 over 2. What we can look at is on a restricted domain, so solve on a restricted domain. You'll see me something like this, solve on x is between 0 and 2 pi, something like this, okay? And then there's going to be another one where I'm going to solve for all solutions. All right, and I'm going to show you and explain that to you, okay? All right, so let's jump right in, okay? Let's go. We got our unit circle ready. So here's going to be our first example, okay? Let's solve this equation. Let's solve sine of x is equal to the square root of 3 over 2. The first part we'll do on 0 to 2 pi. Okay, so what that means is on one revolution of this unit circle here. And then the second way I'm going to do it is I'm going to solve for all solutions. And I'll explain that. All right, so here's the basic procedure, okay? You're going to look at this. You're going to say, okay, sine of x, when does sine of x equal the square root of 3 over 2? And I'm just looking from 0 to 2 pi. So look, sine, cosine. So sine is the second value in the ordered pair. So look, here, let me erase that. Look here, at pi over 3, sine of pi over 3, so I'm going to write that here, sine of pi over 3 is indeed equal to the square root of 3 over 2. And then look, anywhere else? Oh, right here. Also sine of 2 pi over 3. That's also equal to the square root of 3 over 2. So look, I found the values of x from 0 to 2 pi. Notice it can't be 4 pi over 3 because that's negative square root of 3 over 2. And the same thing here with 5 pi over 3. So look, it's right here. It's pi over 3 and 2 pi over 3. So we solved it just by looking at the unit circle. So x is equal to pi over 3 and 2 pi over 3. We solved by inspecting the unit circle, okay? Okay, now what do I mean for all solutions? So recall that sine is a periodic function. So it's a periodic function. Okay, so what that means is the sine graph, if you were to just sketch sine of x, right? All right, it would look like this. It would keep going forever and ever, right? So there's an infinite number of times, okay, that sine of x is equal to the square root of 3 over 2. And the period, and this is we got to remember, from all our previous lectures, right? So the period of sine of x is 2 pi. So this pi over 3, you go another 2 pi, you get back to it, okay? So what you do to solve for any solutions is this value, pi over 3, it gets repeated, or the value of square root of 3 over 2 at pi over 3 here gets repeated every 2 pi. So one solution, the way you do this, is you go pi over 3 plus 2 pi, because that's the period, times n. And this is where n is an integer. And then you do the same thing for 2 pi over 3. You go x is equal to 2 pi over 3, and then, hey, every 2 pi, it repeats itself. Okay, again, where n is an integer. Sometimes you'll also hear me say something like this, for any integer n. Okay, same thing. Okay, but this is how you show, all right, this general solution. Okay, so basically you say, okay, whatever the period is, 2 pi, and then you multiply it by n, where n is an integer. Okay, so like cosine is the same thing. Cosine, the period is 2 pi. And then we'll do an example with tangent. Remember, the period of tangent is pi. Okay, so you'll continue to see this. All right, let's do this lecture here. I've got 7 examples planned for us. So this is just the first example. All right, so let's jump into example number 2, and then you'll continue to see the procedure here. Okay, let's solve. Again, let's look at this one. 2 times cosine of x plus the square root of 3 is equal to 0. Okay. And then again, we're going to do this just like we did before, on 0 to 2 pi. And then 2, we'll do this for all solutions. All right, so the first thing you have to do here is you have to say, well, I've got to get cosine of x by itself. All right, so you're going to subtract the square root of 3 over. So you have 2 cosine of x is equal to the minus square root of 3. And then you're going to divide by 2. So you're going to say, okay, when does cosine of x equal minus the square root of 3 over 2? All right, so look, here's what you got to do. Cosine, you're going to solve by inspecting with the unit circle, okay? So you're going to say, okay, cosine is the first value on the unit circle. So that's here. So one solution is going to be 5 pi over 6. And then look, here's another time when the first coordinate is negative the square root of 3 over 2. It's 7 pi over 6. All right, nowhere else does the first coordinate be equal to negative the square root of 3 over 2. So look, you have one solution, x is equal to 5 pi over 6. And then your next solution is x is equal to 7 pi over 6. So again, cosine is a periodic function. And its period is 2 pi. So to do the general solution here, okay, solving for all possible solutions. Well, look, you take these two different values here. So one solution is when x is equal to 5 pi over 6 plus 2 pi n, okay, and this is for any integer n. Right? And like, remember what the integers are, right? It's like -3, -2, -1, 0, 1, 2, 3. Okay? So like, even when n is equal to 0, you get back to this first one, 5 pi over 6. And then you get x is equal to 7 pi over 6 plus 2 pi n. And this is for any integer n. So we got it. So you can see, like, the way you're doing this, right? The way you're doing this is you're starting by inspecting the unit circle and going from there. All right. Let's try another one. All right. So let's solve this one. Let's look at 5 sine of theta, so now I'm just using theta instead of x, plus 1 is equal to 3 sine of theta. All right, so again, I'm going to go and do, on 0 to 2 pi, and then I'm going to do all solutions. All right. But how are we going to solve this, right? So it's like, let's start by, moving this over. So 3 sine of theta minus 3 sine of theta. So look, 5 sine of theta minus 3 sine of theta, that's just 2 sine of theta. Plus 1. This is now 0. Subtract the 1 over. So you have 2 sine of theta is equal to minus 1. Divide by 2, and you have sine of theta is equal to minus 1/2. We got it. All right, so look. Let's do on 0 to 2 pi. So look, all we did was we isolated the trig function by itself, okay? All right, so let's look. When does sine, okay, so sine is the second value. So when is sine -1/2? So it looks like right here. Okay, that's 7 pi over 6. And then the other time, boop, right here, 11 pi over 6. And then so you can see the procedure, right? How are we going to find the general solutions? You're just going to tack on to each one of these. You're going to go plus 2 pi n for any integer n. And that's going to give you all solutions. So look, that's because sine, right, is a periodic function with period of 2 pi. 7 pi over 6 plus 2 pi n. This is for any integer n. And then also x is equal to 11 pi over 6 plus 2 pi n. This is for any integer n. All right, hopefully not too bad. Hopefully this is kind of, kind of making sense here. All right. Let's try another one, right? Repetition here, okay? So let's go into example 4. Let's solve -2 times sine of x is equal to the square root of 2. All right, and again, what I'm going to do is on 0 to 2 pi, and then 2 for all solutions. You know what, look, this is a good one, right? You've seen me do 3 problems, but like this is a good one to like pause and see if you can, if you can solve this without my help. So I'll be quiet for 5 seconds. Hopefully you solve the video, or pause the video and give it a shot. All right, but look, this is how I would solve this, right? Got to get sine of x by itself, so you're going to divide -2 over. So negative square root of 2 over 2. All right, so look on the unit circle. All right, when does sine going to be equal to negative square root of 2 over 2? So you're going to, right here, boom, first one. Add 5 pi over 4, and then what's the next one? 7 pi over 4. 5 pi over 4, and 7 pi over 4. My handwriting is pretty terrible here. Sorry about that. So we got it. And then, you know what? Boom, you can see how do you do the general solutions? X is equal to 5 pi over 4 plus 2 pi n for any integer n. And then x is equal to 7 pi over 4 plus 2 pi n for any integer n. All right, let's do a cosine problem, and then I'm gonna do 2 examples ending with tangent. Okay. All right, so here's another one I'm gonna put up, and you should try solving. So example 5. All right, so let's solve 7 cosine of theta plus 9 is equal to -2 cosine of theta. All right, and then again, we're going to do 1, let's do on 0 to 2 pi, and then 2 we'll do for all solutions. So look, how are you going to do this, right? So, give it a shot. I'm going to be quiet for a second, all right? And, see on your own if you can, solve this without my help, right? So give you another second to give it a shot. All right, so, what you would do here, you want to get cosine of theta by itself. So you're going to add 2 cosine of theta to each side. So you get 9 cosine of theta plus 9 is equal to 0. So you would subtract 9 over. So you get 9 cosine of theta is equal to minus 9. And then when you divide by 1, okay, you know, what do you get here? You get, when you divide by, 9, all right, you get negative 9 divided by 9. So you're just looking, you're saying, okay, hey, when does cosine of theta equal negative 1? So, only one place, right here. Only at pi. All right? So your only solution here on 2 pi is you go x is equal to pi here. And then to find all solutions, again, you're just going to start at pi, and then you're going to go plus n pi, where n is any integer. But what you can also recognize here is that when n is equal to, if there was no pi here, when n is equal to 1, you would also just get pi. So literally you could just write n pi, where n is any integer. Oh, I'm sorry. 2 pi n, sorry. Okay. And we're going to have to actually, on my apologies, we're going to have to leave it like that. Sorry, a little bit of a typo there. Sorry, doing so many of these already, it's already getting the best of me. So like that. All right, let's now talk about tangent, okay? Because we've done a lot of cosine and sine. So let's do 2 problems here with tangent, okay? So what we've seen here is with sine and cosine, the period is 2 pi, right? So for all these problems, 2 pi, 2 pi, 2 pi. All right, but now with tangent, okay? All right, let's solve tangent of x is equal to 0. Okay, so we'll start 1 on 0 to 2 pi. And then 2, we'll do 1 for all solutions. All right, so you notice here what you look at is you're like, oh, geez, there's no tangent on the unit circle. But right, like the way you would solve this, so just kind of like recall. Tangent of x is the same thing as sine of x over cosine of x. So really what you're doing here to solve this okay, you're going to replace in here the identity. All right, so you're going to say, all right, well, when does sine of x over cosine of x equal 0? All right, so look, so, cosine, cosine doesn't matter. So really what you're doing is you're looking, when does sine of x equal 0? Okay, so that's going to be here, okay, right? Or, sorry, that's going to be here and here, just like that. All right, so what you got here is you got when x is equal to 0 or when x is equal to pi. Boom, we got it right here. All right, so now for all solutions here. Tangent is a periodic function. All right, and tangent's period is pi. And look, you can see this. Pi, 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 pi. You're getting back to 0, okay? So look, you don't want to, I know it seems like, oh, you do 0 plus n pi. 0 plus n pi is just n pi. So the solution here is just n pi, where n is any integer, or for any integer n. All right, so we got it. All right, let's end on one that's a little bit harder with tangent, but also, also more fun, okay? All right. So example 7. Let's solve tangent of x is equal to the square root of 3. And so again, here what we're going to do is we'll do it again 1 on 0 to 2 pi, and then we'll do it 2 for all solutions. All right, so look, here's what you're going to do. You're going to say, tangent. All right, well, tangent. So change tangent to sine of x over cosine of x. All right, so now this is what I'm solving. I'm going to solve when does sine of x over cosine of x equal to the square root of 3. Well, look, notice that you want there to be a square root of 3, all right? And you want basically, that everything else to cancel out. So what you want to do here is you want to start by looking, when does sine of x have a square root of 3 in it? Okay, so start by that. So when does sine of x have a square root of 3 in it? Looks like right here, okay? And so when you do, watch what happens here. Pi over 3. Okay, so if I go tangent of pi over 3, that's going to be sine of pi over 3 divided by cosine of pi over 3. Well, that's the square root of 3 over 2 divided by 1 over 2. Look, when you do keep, change, flip, the 2's will cancel out, and you're left with just the square root of 3. So one solution here is pi over 3. We got it, okay? Now here's another deal. You might say, oh, well, what if I use 2 pi over 3? But notice how you have a negative and a positive. Well, that'll result in a negative square root of 3. So I just want it to be a positive square root of 3. So it's like, is there anywhere else maybe where this could happen? All right. Well, if you look here, all right, check this out. Sine here is sine when you do 4 pi over 3. Watch what happens. You get sine of 4 pi over 3 divided by cosine of 4 pi over 3. Well, look, you get negative square root of 3 over 2. Oh, this is why I needed that one. Yeah, look, the negatives will cancel out and you'll get back to positive the square root of 3. What's really interesting here is the distance to go from pi over 3 to 4 pi over 3. That's the distance of pi, because if you look, they're right diagonal from each other. So your solutions here, this is how you're going to do this one. You're just going to start with pi over 3. And then you're going to add, remember, going back, the period is pi plus n pi. And this is for any integer n. The reason you don't need to do 4 pi over 3, okay, is when n is 1, pi over 3 plus pi gets you 4 pi over 3. So you'll only need that one right there. All right, class, I know there was a lot here. I know there's a lot of, tricky examples, and, the more you practice, the easier this will get. And I will continue to, I'll follow this video up with more lectures now, solving, more interesting and more complex trig equations.